Alright class, as promised previously, now we will look at the development of microstructure in binary isomorphous phase diagram upon cooling of carbon-nickel alloy. We will consider the CO as 35 weight percentage of nickel here. So here is the line, alright. So we will take a look at all the microstructures along this line of 35 weight percentage of nickel. As you know that this one is 100% nickel and this one is 100% copper. Alright. Let's see at point A. So this is point A. Here, along the line of 35 weight percent of nickel, at point A here, around 1300 degrees Celsius. Here is the pure liquid region. So it is 100% liquid here. So the composition of liquid is 35 weight percent nickel. Is the same as the CO here. And the fraction of liquid is 1 because it is pure liquid region. And upon cooling, when we take at point B of temperature 1270 degrees Celsius, where it is just slightly below the liquidus line. Okay, the microstructure here is mostly liquid, but alpha phase begins to nucleate here. That is why you can see all the little dots of all the little blue dots here indicates alpha begins solid begins to nucleate inside the liquid region. So here we can say that the fraction of liquid is almost 99% and fraction of solid is around 1%, where the composition of liquid is 35 weight percent here, and composition of solid, because this one the composition of liquid is 35 weight percent because it is at the liquidus line, and when you draw a tie line here until here, so you can get that the composition of solid is around 46 weight percent of nickel. And you can get the fraction of liquid and solid from the lever rule when you already know C alpha and Cl. Alright, at point C here, point C is in the two phases region where there exists the solid phase and also the liquid phase. At point C, the temperature here is around 1250 degrees Celsius. You can see that more alpha phases develop here. So when you draw a tie line at point C, the one that intersects that the solidus line will become your C alpha, and when you drag down the line, it is around 43 weight percent of nickel. And when you look at the tie line, the one that intersects the solid liquidus line here, and you drag down the line to know the composition of liquid, you get it around 32 weight percent of nickel. Okay, from this tie line, you know the Cl and C alpha. Then you apply the lever rule. you can get fraction of liquid and fraction of solid. Alright, at point D here, okay, upon cooling until you reach the solidus line at point D, the microstructure is mostly solid phase, but some liquid remains. Okay, so when you draw tie line here, you get the liquid as the Cl as 24 weight % of nickel, and the C solid composition of solid around 36 weight % of nickel, because it is just slightly the solidus line. And when you apply lever rule there, you will get the fraction of liquid as around about 8%, and the fraction of solid as around 92% of solid. Looking at point E, okay, point E here at about 1200 degrees Celsius. Okay, the microstructure here is in pure solid region, and we can say that the composition of solid equals to 35 weight % of nickel. Composition of solid is equal to composition of, here at point E, composition of solid is equal to composition, the concentration of the composition given here, which is 35 weight % of nickel. And the fraction of solid is 1 here, because solid is the only phase present in this region. This is the pure solid region. Okay, thank you for listening. Till we meet at the next lecture. Thank you very much.